We are glad to give an introduction to our method at the CVPR 2021 Image Matching Workshop. Our method achieves the best performance in the restricted key points category, and we will illustrate our method in 3 parts. First, we will introduce our pipeline. We use pre-trained superpoint during key point detection stage and fine-tuned superglue during key point matching stage. Specifically, we distorted the image with random homography adaptation to improve the repeatability of key points. Then, we use instance segmentation and semantic segmentation to remove useless area. Finally, the origin and the distorted images are fed into the superpoint model to extract key points and corresponding descriptors. To adapt the submission format, we use an AutoEncoder model to encode the feature dimension from 256 dimension to 128 dimension. During the matching period, the decoded descriptors are fed into the fine-tuned superglue to obtain the matched pairs. Finally, Descriptor is used to reject the outlier matches. For the training of superglue, we use Oxford and Paris dataset to train a basic model with homographies and photometric distortions. Then, we use mega depths without test set on phototourism to fine-tune the basic model. We decrease the bin score during inference, which aims to balance the precision and the matching score. And the training settings are displayed in this page, and the final results shows that our setting achieves comparable performance with the official model on the same test pair set. To adapt the official submission format, we also train an AutoEncoder model to compress the descriptor. The MSE loss is used to constrain the input descriptor and the decoded descriptor. The final submitted descriptors are encoded to 128 dimension, and the decoded descriptor is used as the input of superglue. The experimental results show that the decoded descriptors achieve similar performance on the validation dataset. In this section, we will introduce the feature adaptation model. First, we perform 49 random adaptations to the original image. Then, we fuse the features of the adaptations with 1/10th weight and the original descriptors together by summation. Finally, we fine-tune the superglue model with the fused features. To verify the effectiveness of our method, we choose 3 validation schemes randomly and compare the similarity distribution between average fusion and the proposed fusion. Specifically, we collect the ground truth matching pairs and evaluate the distribution of cosine similarity distance. Then, we calculate the distribution difference between average fusion and the proposed fusion. The experimental results show our method obtain more pairs than average fusion on the high similarity section, and less pairs on the low similarity section. Finally, we will share some effective tricks during the computation. First, we split forebackground with semantic segmentation and instance segmentation. We mask including person, sky, car, bus, train, chalk, and advertising board during key point extraction stage. All segmentation results are generated from open source algorithm, which is shown below. Moreover, for some skins with status, we ignore the labels of person to avoid the misclassification. Besides, we try different thresholds of DE Ginseng and evaluate the AUC at 10 degrees to find a suitable threshold to evaluate for each skin. At last, we use 1 for phototourism, 2 for Prague Park, and 1.2 for Google Urban. This table shows the results of different versions in validation and leaderboard. The green one achieves the best performance in this competition. Finally, we want to share an interesting result with two-stage adaptation. For image pairs with few matches, we adopt two-stage matching progress. We split each image into 9 half-size patches and extract matches between the patches and the full image. The matches are filtered by the sharing point set between patch to full. The pair with the most matches is selected as the final result. The visual result shows that our proposed two-stage can increase the matches significantly, and we will verify the effectiveness on the test set later on. Thank you.